Welcome back, chemistry fans. Today we are going to work on the warm-up number 10. So let's get right into it so that you guys know what to expect if you are not here for this day. We are going to, let me zoom this in so we don't have both of them. This is the next one as well. All right, so on this one, what we are asking to do is to figure out the molar mass. So what you have to understand about the molar mass, it's not the atomic mass, it's the weight of each one of these elements times the number of atoms. So there are 6 carbons, there are 16 hydrogens to start, but there's 2 more over here. So that actually makes that a total of 18 hydrogens. And then the same distribution means that there are 2 oxygens over here. So we got to do 16 times 12.011 for the carbon. I get this off of the periodic table. So if you're unfamiliar with what that would mean, I am looking underneath that block right here, and you see where my carbon says that the weight is 12.011. My hydrogen is going to be 1.0079. And what was the other one? Oxygen is 15.994. So let's get all of that information put together into one molar mass. So I'm going to have 18 times 1.0079, and I'm going to have 2 times 15.9994. That is not 20. That is 2 oxygens. So 12.011 times 6, that's going to give me 72.066. 18 times 1.0079, that's going to give me 18.1422. And 2 times 15.9994, that's going to give me 31.9988. You add, sum all those together, 72.066 plus the 18.1422, and you get 122.207. With sig figs, you should have 5 sig figs because this is the lowest number of sig figs, so is the second value. So your answer would cut off 122.21 grams. All right, next, we've got this nice distribution. It's a mass spectroscopy graph. We have to figure out what element this is based on nothing else but these lines. But we do have a little bit of information here. We do see that there is a percentage of each one of these. So at 90%, it's at 50%, or at 90 is the mass number down here. That's mass number. It's at 50%. Down here, we've got it somewhere at about 10% for 91. And then it looks like 15% for 92, and an additional 15% for 94, and then finally 5% for 96. So we have all of our percentages, and so we can do an average atomic mass to calculate this. The other thing we could do to make a quick estimate is we know that it's not anything less than 90. And we know it's not anything greater than 96. So let's go look at the periodic table so we can at least eliminate down some of our choices. So between 90 and 96 means that we're looking at these elements right here: zirconium, niobium, and molybdenum. Now, many of you would guess 91, and that wouldn't be a bad choice. The actual answer is going to end up being niobium. Once we do all of the math associated with this one, it's going to end up being that the percentage is somewhere around 92. And if we were to look at where, again, the average is for these, if we were to draw something like a triangle, the average is falling somewhere in here, because you would have half as much space as you do over here. So that's another way that you can probably make a good estimate about this one. All right. So with that said, that is the end of this warm-up. Thank you for practicing with me. Goodbye.